It is my great pleasure to introduce today's speaker, who is a speaker both for the EEB seminar series and also for the Lacretz Center Conservation series. So this is George Wittemyer from Colorado State. And George did his undergrad work at Colorado College and then did a Fulbright scholarship which brought him to Kenya, where he began a long affiliation with a nonprofit there called Save the Elephants. And George began a field program which has turned into a really great long-term observation program, studying a population of elephants in northern Kenya. Got a couple of years of that under his belt, and then came up to Berkeley, which is where I came to know him, because we were lab mates in Wayne Getz's lab at Berkeley. And George was always a very entertaining lab mate, because he would bring back one or another thing from Africa, including malaria, which he'd just sleep off on the lab couch, or a great story about getting attacked by a bull elephant, having his truck thrown around for a while. He escaped that one by a whisker. But then came out of the PhD, did an NSF International postdoc, enabling him to do more work around Africa, a bit more work at Berkeley, and then settled in at Colorado State. And he's really been, I think, a case study in how much value you can get from a long-term field program by employing a whole set of different techniques. I don't know how many we're going to hear about, but starting with individual observation, molecular ecology, stable isotopes, GPS collars, remote sensing, the whole works, and getting at questions from individual behavior through to demography and ecology, and as I think we'll be hearing today, into conservation, which is kind of where this system stands now. One more thing before I hand over to George. He's giving another talk, being Glutton for Punishment, at 4 p.m. In Lacretz 110, which is going to focus more on the behavioral and even cognitive aspects of elephants' ecology. But for today, we hear about impacts and drivers of commercial trade in African elephants. All right, thank you.
So I'm one of Jamie's first students, actually. He doesn't know this because you're in the cohort, but we would go. He was one of these superb graduate students that was incredibly good at mentoring all of us as well. So we had a really great cohort we went through, and we owe that to Jamie, I think, a lot. But anyway, so thanks for having me here. I'm going to talk to you today about what's been the major impact into my research life and my system. And so it's something that I actually feel like I have have to present to people when I get the opportunity to let them know what's going on. And there's a couple graphic pictures, including the one I have on the cover, but this is the reality. And so I think it's important when we talk about this concept, we can stay removed from the system and the impacts by just talking numbers, but I personally think it's important to actually show what's happening so people can get the visceral reaction to it that it merits, in my mind. But anyway, I'm going to talk to you a bit about what's going on with some large-scale commercial harvesting of large mammals across the globe, and I'm going to focus on elephants because that's my system. But we're seeing this pick up across species, and we're sort of entering another facet of over-harvest by humans. And these impacts with elephants and with multiple species really started with when we started getting empires, different human civilizations of high enough density that they were able to have these sort of multi-tiered societies, and certain levels would want to extract goods for whatever reason. Is that better? And so the elephants really came into play in the Roman times. Ivory was highly valued commodity, as it has been across many cultures, and the Roman Empire over many centuries really denuded northern Africa of all its elephants. And so at the time, the Sahara was more mesic than it is today, and there was elephants there. They were largely harvested to feed the Roman appetite. Europe and America really set off the next episode of over-harvest of elephants for ivory, coupled very heavily with the slave trade. And so large swaths of the Ivory Coast, West Africa, and Central African regions were denuded both of people and ivory at the same time. And so you had these amazing specimens going out. And there was also movement out of East Africa at this time, less heavily hit, and Southern Africa was also, elephants were eradicated out of Southern Africa for the most part at that period. Then we had America, Europe, and Japan coming into the consumptive areas of ivory in the 70s and 80s. And that's where the first time where we actually have some estimates of what actually happened. So we probably went from 1.2, 1.5 million elephants on the continent down to 400 to 500,000 over a 10-year period. This was coupled with the Cold War. Weapons were being flooded into Africa for various geopolitical games, and those weapons were used for a variety of things, including harvesting elephants. And so we've sort of been through these multiple cycles. After these cycles happen, you tend to get periods to the end of the 19th century. Impact was really stymied by the end of slave trade. Then the world wars kicked in, and that really slowed down extractive harvesting in these systems. We were busy killing each other. We didn't do as much harvesting at those times. The 70s and 80s was a more contemporary example of how you play with over-harvest. And there's a lot of debates how we have it, and I'll end with maybe some discussion, hopefully if we have time, on what we should do now. But the 70s and 80s period ended with real global recognition of the problem going on, and there was a sort of a large-scale environmental movement coupled with this, and I guess consumptive use of animal parts became sort of out of fashion in the West, and that collapsed the market to a large part. Japan at that time was the impenetrable culture that would never change its ways. In Japan, ivory is much less consumed in Japan today than it was then. There has been a cultural shift in Japan as well, although be it slower than what happened in the West, towards not valuing this type of a product. So I think that's an important backdrop just to have in mind as we go forward. Sometimes my talk can be a little depressing, depending on your perspective, and so I just wanted to pop in that there's examples of success with this. The Serengeti elephant system, this is the collapse in Serengeti from the ivory slave trade. There were no elephants in the early part of the 1900s in Serengeti. They came back. They actually colonized somehow. Numbers got up. We don't know exactly how it was related to historical densities, but poaching came in and hammered them down to low densities. There's interesting things going on between Serengeti's on the border of Kenya and Tanzania, and the elephants would go north or south across the border depending on where the pressure was, trying to escape. And then we had the ivory brand, the global recognition of this problem in 1989, and again the population started recovering. And that's really when I started my work, was during this recovery phase. And so just giving you an idea of the species distribution, Roman time era is sort of this purple idea of what we think. By the 79, when we start actually doing census and trying to get an idea of it, you have all northern gone, western pretty much finished, and southern finished, and a few populations introduced in these areas and doing quite well. 2007, after the 80s eradication, we see that we're just getting more and more disparate populations eradicated from a lot of areas, and a lot of fragmented populations. And this actually was a period of expansion in the elephant history. And then in the last few years, we've started to see a pickup, certainly in best exemplified by the press. We've had a lot of coverage of this issue in a variety of areas, and there's been wide-scale recognition that, again, we're hitting into another epoch of over-harvest of these commercially used species. Elephants being a good example of that. And unlike what we had before, a lot of this hasn't been done by the military the way it was originally, but we have seen examples in Cameroon and Jaw. They had the Janjaweed came in. The Janjaweed are sort of the Darfurian genocidal rebel groups that you've heard about on horseback, very effective killers. And they would go in and they repelled the Cameroonian army actually in order to harvest elephants in National Park in Cameroon. So there's been global, I guess as we've had sort of these quasi-terrorist or I don't know what you call them, marauding militia groups involved in this. There's been some security concerns. So we're getting interest on this issue from a variety of areas, actually. So I'm going to start today. I just wanted to give you sort of the breakdown of where we are. I'm going to start today talking about some of the work I've done in the system I've done, which I know most intimately, and that's really been a sounding board or a case example of what's going on for this species. And so I'm going to start today talking about some individual-based research we've done looking at elephants in Kenya, and I'm going to talk about sort of human and ecological interactions in demographic processes in that population. And then I guess I'm taking you through my life progression. So this is sort of the work I was doing. One time we were in this happy day, the elephants were expanding, we're watching natural processes influence that process, and then we had the human impact change, or the scale of the human impact change, and largely economically driven. And so the second part is really building off the baseline the intimate baseline we knew from Samburu, and trying to start interpret the global, or I guess the continental level processes that are happening. And so we're going to go into that part on the second half. And then hopefully I'll try to get through some of this stuff quickly. We can talk a little bit about commercial trade of endangered species. And it's a big question out there that we're dealing with now, is what's the solution to overharvest of these species? And there's a lot of economic arguments about how we need to embrace the economics of this and use it as a solution. There's a lot of people out there who say economics and natural resource, the modeling, the framework we use for using economics to solve natural resource management issues is inherently flawed, and we just see over and over examples of failure in that model. So we're hitting critical points with some of these species where we've got to figure out something relatively soon. So I want to end with maybe touching on those topics a bit. So just for those of you not familiar, this is Africa. This is the distribution of elephants. The dark green is known, the light green is possible. So the largest mammal on the planet, we still don't actually know how many there are, and we don't know their distribution, which is kind of interesting. But it turns out they're not that easy to count, especially in the forested system. And I'm going to focus in on Kenya, where I've done a lot of my work. We call it northern Kenya, but it's really central, and it's Samburu, Laikipia area, and there's 2 national reserves that we've based in. I just want to point out that we've got Somalia to our east, we've got Ethiopia to our north, and southern Sudan to our north, and Uganda to our west. And all of those countries during the time I have been there have been in civil unrest. Somalia is chronically in civil unrest. And the result is that we're quite a volatile, politically a volatile area, and it's heavily armed, and which is a lot of the context that I'm working in is because there's so many weapons going through, and the weapons are actually highly tied to the U.S. Foreign policy interventions. And so one of our big things, as you might know, is being involved in Somalia to ensure militias don't take over, Al-Shabaab being the militia there. And so we have funded and equipped the Ethiopian army and the Kenyan army to some extent to deal with some of the problems in Somalia. And as that equipment goes in, the weapons that are being traded or being used or being equipped by the US come into our system and are used for the local civil unrest problems and the poaching of elephants. So when I started, AK-47 was everywhere. It's a classic Somali gun that you would, in your mind, you might picture with Somalia. And in the last sort of 10 years, early 8 years, M16s have become, which is our American-issued weapon, have become classically used in our system, as well as other higher caliber weapons. So I have tons of anecdotes on poachers that are they're fascinating, tough as hell people. Anyway, I just wanted to show you the system. Samburu, Buffalo Springs National Reserves, here in the middle of this greater population area that we call the Samburu elephants. Is arid. They're highly dispersed. They go all over the system. Actually, this gray is showing an outline of where they were in the first year of radio tracking we did. It's since expanded. It covers an enormous area. They use a huge area. So a highly mobile species in an arid system. It's not easy to manage them as a result. When I arrived on my Fulbright in '97 out of my undergrad, I'll tell this to the undergrad talk. It's one of my examples of things you can do out of an undergrad. I went up and identified all the elephants in Samburu, doing basic census for the Wildlife Service there. I was an intern, Kenya Wildlife Service. And we know all of them. We monitor them all. We go on weekly routes that we go through the reserve and just see who we identify all the elephants, look at demographic processes, social interactions, that kind of stuff. That's just being recorded constantly. And a lot of the work was originally focused on social properties, network structures, how these are shaped by this really, they're really quite a complex and interesting species socially. And so we're looking at these dynamics of these matrilineal structures and how they interact with each other, how the age of the mother and her status in the population influences her offspring, and all these neat repercussions of that strong sociality in that system, and it's changed a lot now. I don't get to play those questions as much. It's a ecologically highly variable system, and when I was growing up, the big drought in Ethiopia in like 1984, Feed the World campaign, all that stuff. I don't know if any of you guys know that, but that was a thing I remember from my system. That was a drought in our system as well. We're very tied to that. So you get these big droughts where literally people die as well as wildlife, and then you have these amazing El Nino surges of water as well, and so of rainfall. And so you get very dynamic ecological system. And I won't get into this, but we've done a bunch of different areas we've looked at, and it's a beautiful place. My favorite place, one of my favorite places. But so later I'm going to talk about a bit of the spatial ecology and social behavioral work. And today I'm really going to talk on some of the human-wildlife interface tying into demography. But there's some other stuff we've done too. And so this is just a graph over time since we started the project to recently, where we're looking at the sort of population growth change, and we have our mortality pretty consistent across time up to this point, and our natality. And so when I think about the system or the work on the system, it's really driven into a natality-dominated period when natality was dominating the trends, and we have a mortality-dominated trend. And 2012 and 13 actually are a really interesting period because we've had good natality and high mortality, and it's going to be interesting to see how things play out. We're really on the cusp of a variety of stuff right now on how this might go in the future, where this population might go in the future. But we've done work on natality just to understand how it works. This stable isotope work on the top is rainfall centered on this whole figure centered on the peak of NDVI. And so rainfall from a local metric, so you see rain comes into the system. A couple weeks after rain comes, 20 days after the peak of rain, we get the peak of NDVI, of the primary productivity in the system. So it's sort of 2-week lag, 3-week lag. And then what we looked at from stable isotope is we looked at hydrogen to get an idea of water, where they're getting their water content. And what you found was that the water content was highly correlated with productivity. So they're getting a lot of their water they're metabolizing from preformed water in vegetation. The C4 diet gives a grass diet, so they're switching between grass and browse. And what you see is they typically start switching to grass a couple weeks after the peak in NDVI. So the flush of growth happens, the grass starts growing, a couple weeks of growth, then they start to feed on it. And so that's what this is showing here, this offset of 16 days there. And then this is conception date. And so that's usually offset. They're conceiving a couple weeks after they start feeding on grass. So it's kind of neat. So it's really ecologically driven natality in the system. And for most of the beginning part of my study, that's what we are seeing in the population trend, just driven by the ecological variation. So probability of conceiving for a female is highly correlated with NDVI. That's one of the pieces of work we put out. So bad years, very few females conceive. Drought years, nobody conceives. They stop cycling. Good years, a large proportion of them conceive.
What does NDVI stand for?
Sorry, normalized difference vegetation index. It's a remote sensing. So you're just you're contrasting. I can't remember exactly which bands, but you're contrasting bands to get an idea of the greenness, so the chlorophyll activity on the landscape. Yeah, sorry about that. Okay, so this is just to show you the difference. This is that natality. This is survivorship curves during the natality-driven period. So you basically can look at it and say at age 40, about 60% of the population of individuals have died by the age of 40 in the Samburu population. So this is females is the solid line. Dashed is males. And so males never did as well in the system, which I'll talk about why, but that's linked to ivory. And then we had, during the mortality-dominated period, the latter half, you just see an absolute collapse in survivorship, the population. So unsustainable status. So that shows this real starkness. And this is actually showing you, this gets to what's driving this difference. This is a number of elephants known in the population that are over 30 years old. And what you see is when I started, there's been a slow loss of, and this includes recruitment into that age class, slow loss of these old males. Females were stable. Old females are pretty stable in the population. Then in 2009, we started seeing a switch where females also start disappearing. And so originally we were looking at some of these demographic trends and wanted to know how things are working. And as I mentioned, it's a relatively politically volatile area. There's a lot of weapons. The pastoralists have a really interesting economic system based on livestock. It's actually, we talk a lot about livestock in terms of meat production, but theirs is really a dairy system, is how they extract protein. They do bleed them and eat the blood as well, but it's primarily dairy is the protein that comes out of the livestock system. And so, so it's really, they're banking, everything economically is banked on livestock. And so we wanted to understand what's going on with deaths and why we're seeing this slow atrophying of older males and what might be related to driving some of these periodic changes we see in annual survival of these older individuals. And so this again is during the best years when the population is growing. And we looked at a bunch of different economic indices, local livestock prices, maize price. Maize is a supplement, especially for food program in the area. Kenya GDP, East Asian GDP, all thinking these metrics might help explain some of the variance we're seeing in survivorship that we can't explain, but ecological factors. And what we found was that adult deaths were highly correlated with seasonal adjusted cattle price. So cattle pricing, as cattle prices got higher, there were fewer adults that died in the system. And NDVI didn't explain any of the variation. So ecological changes weren't explaining mortality of adults, but cattle price was. So when things are good economically for these pastoralists, adult elephants didn't die. When things were bad for livestock, adult elephants died. And opposite to that was the juveniles. Juveniles were totally structured mortality by NDVI, by primary productivity in the system. And so when primary productivity is high, offspring survive, adolescents survive. When droughts happen, juveniles die. So that's sort of this strong relationship between NDVI. And so I think my interpretation of this is you've got these rural communities, and basically what they're doing is they have to diversify. There's not very many developed economic activities in the system available to them. And so they're doing their pastoralism. When pastoralism gets hit for whatever reason, they start to switch to alternative revenue sources, and one of those is ivory. But it's not a mainstream source at the early part of my study. So that was sort of where we came. And so now I'm going to get into really what we wanted to start understanding was how does this cryptic killing, illegal killing, how much is happening, how does it change over time, and what's going on with the population because of it. And so quantifying cryptic killing is really a complicated story to do. It's a really complicated thing to do. We have major problems with it. Any cryptic mortality source, so be it disease driver, it's really hard for us to partition disease mortality rates from other sources, or in this case, human-caused mortality sources. But it's really critical for us understanding population processes. So we're trying to solve this. And the way we've decided to do that is we're going out. Nice thing about elephants is they're big, and when they get shot, they're being shot for ivory. The body's left. And so we started doing carcass surveys on a large scale in the ecosystem. So again, the area I started was Samburu National Reserves in here. And these are carcasses that we have found basically through informants in the community. The pastoralists are covering the entire ecosystem with their livestock. And when they hit when they hit dead elephants, they inform us of the location. We go check the cause of death. And so the red ones are illegally killed. Green ones are natural deaths. White are unknown. And I think purple are conflict, which is also illegal. But at one time we were trying to discern areas of conflict where that might be non-ivory driven killing. And so this covered the whole period of the study from 2002 to 2012, that date is. And I'm going to just show you what it looks like. This is what we have to go do, and this is what actually my work changed to. I started doing behavioral ecology stuff, was having a great time with elephants. They're really intelligent, amazing social species, and then it really switched in 2010, 2009 to doing a bunch of surveys of dead elephants, and dead elephants that I knew, some of whom I watched born and grew up, and it's been really unpleasant. But this is basically what we come up trying to figure out who the elephant is from her ear pattern, the carcass. You get the hacked out face, the trunk cut off, blood pool, and then we'll try to usually find the cartridges used. Nice thing about cartridges is there's quite a bit of cartridge surveillance going on and trying to understand where bullets are coming from, especially in relation to terrorism. So just trying to get an idea of illegal arms flow and weapons flow. And so there's actually people that you can just send cartridge casing identification numbers, and they'll tell you when the bullet was made, where, etc. So we've done a lot of this sort of forensic work as well. This is hard to see, but it's motorcycle tracks. So in this case, they shot her, a motorcycle came in and took the ivory out. So this is one with older carcass where we pulled AK-47 bullet out of her forehead. So this is how we're identifying the cause of death of these different systems. And then the other one that we've been involved in is doing real-time monitoring, which is another aspect of my research that I'm not going to talk about at all when I'm here. But with GPS collars, we're looking at movement properties and trying to identify, use behavioral switches, such as you see here, where you have sort of the normal daily movement pattern of an elephant, and this is when she becomes mortally wounded. So using these sort of massive switches in behavior as a algorithmically identified warning signal for us. So I get it on my cell phone, actually. Gets sent that we have an animal that has, this is where they've slowed down critically, that it's a high concern. We also get completely immobile. And so we're using that to try to respond more quickly and effectively in the field. So this is a case where this female, this is the matriarch actually, who was collared, mortally wounded. This is her daughter, killed, and we found the body after she came in, and we got this warning, and we went and explored her path and found the poached elephant. So this is sort of how we're collecting that data. And I'm just going to show you this out of interest. So you can see this is like normal elephant behavior. This is the river, Wasanyura River, down the middle of the park. Our camp is actually right about here. And so she's basically feeding and moving around, eating. This is during the hot season, spending a lot of time on the river. And then as they do, because of the food, they always go out. Here she's hitting this wetland, which I wish was in the park, but it's not. And so she's going back in and back using this wetland during night. You can see the time of day up there, and feeding at that time of day at night. And then one day she shoots into the park and stops moving altogether. And so that's like immediate population change. And that's the stuff we're using through algorithms to identify as we distribute radio collars across the system. And so you see she's finished. She no longer can move. See in the water. This is what they do, come to water and die a lot. And so then we went up to her and found her, and this is what she looks like. So mortally wounded, and eventually, so we, I'll spare you the details, but yeah, so then we put them out of their misery. And I have actually, as I've been making these slides, I have a number of these slides of elephants we've known poached. And so we're dealing on an individual basis. We have incredible access, I guess, to understanding intimately what's going on with these elephants. And because of that, we've been leveraging UN programs have come. We've had heads of state come, and we've introduced them. Yao Ming was doing a China education program. Li Bingbing also came. She's like a UN Goodwill ambassador. Li Bingbing is a really famous movie actress in China, and Yao Ming's the basketball player. So they've all come, and so because we can introduce them to elephants and then introduce them to poached elephants, unfortunately, we've sort of been a major catalyst for that sort of interaction, that sort of outreach work. So that's another aspect of this work that's totally changed. We're really focusing on outreach. So over time, we have this carcass data we've really invested in collecting, and the question is, how can we interpret that carcass data to give us an understanding of what's going on? And originally the idea was we were actually just going to look at raw number killed. So raw number of elephants killed would be this metric that would tell us change in pressure. But the trick with raw number of killed is it really depends on your on the effort being conducted, and unfortunately these systems are not really well developed and the effort metrics aren't collected properly, and so we haven't been able to use raw numbers to interpret much of anything. It's really an index of functionality of whoever's collecting your data. So I think our metric, this is our metric based on my research project specifically, and it's pretty, I think it is actually a decent metric of what we have happening. And so what you see is, we had that natality-driven period I talked about. We have 1 or 2 we'd see every now and then killed, and then we switched in 2009 and we start seeing higher numbers of elephants. This is the known population poached that we find. So we certainly don't find everything. And with the carcasses, what you get is a ratio. So the proportion of carcasses you find that are naturally dead versus the proportion that are illegally killed gives you this idea, this proportion of illegally killed that helps you interpret sort of pressure changes. And this is our system. And the trick with that is you can see it's highly variable depending on what you find. And also in 2009, we had that's when it really started, the illegal killing happened, but it was also a big drought year. We had a lot of natural mortality in the system, and so the proportion went down. And actually, I didn't know we had a poaching surge on our hands until partway through 2010. Even then, we were really questioning it. And there was a big deal of like, if we're going to come out and say that poaching is now out of hand. And when we first came out and said this, we had a number of people viscerally attack us and say, you guys are always overstating what's happening. You're blowing this way out of proportion. You're dealing with a local issue. All these sort of interpretations. So what we decided to do is we take the binomial proportion and variance of carcasses illegally killed, and we use that to adjust the known total mortality rate. We know the total mortality rate of the individual identified population. We know the proportion of carcasses that we're surveying in the field, and from that we can derive the mortality rate from illegal killing. And so this is what we did in the Samburu population, and we can also then partition it to figure out the natural mortality. So we can partition the total mortality rate into natural and illegally killed. And this has been a big question we've always had, is what level is this actually at? Is it a high enough level? Is it unsustainable or not? We're seeing thousands of elephants killed. Is that unsustainable or not? And it's a critical question. It's not easy to answer. And so then we put this in a Monte Carlo simulation framework where we're drawing from our proportion and variance of illegally killed carcasses, as well as our mortality estimates and variance around our estimates of total mortality. And what we get from that is we get this sort of nice thing where we can partition illegally killed levels in red from natural mortality levels in gray. And so this is Samburu, this is natural mortality. It sort of bumps around rate, and the illegal killing levels quite low. This is based off that carcass sample and the known mortality. And on the black line here is, we don't have very good information of this earlier because we weren't monitoring it. But this is the ivory price given to us by interrogated poachers arrested. And so we're getting some information on what the local price is. And local price turns out to be a really complicated story. It differs by tribe, it differs by who you are, it differs by who you're trading with. So this is a coarse metric, but it gives you an idea. And what we see is we're bumbling around. We have some occasional droughts come in and kill kids, it's basically babies during these droughts. And then 2009, we had an epic drought. And I don't know how this relates to the overall illegal killing, but we had a surplus of dead elephants, and it might have helped start some of the ivory flow in the system that then carried on through. We don't know about that. So that's the natality-driven period. And at $33 a kilo to the poacher, once it got above that level, we started seeing serious problems. And this level at sort of a 4% illegal killing rate starts to be excessive, and the population started to decline at that level. And so we got that after about $33. Unfortunately, it's kept climbing. In 2011, we peaked, probably 8% of the population was killed for ivory, and it's now bouncing around between 6 and 8, basically, which is too high. So again, this is that same figure. This is our mortality rate, our red spike in illegal killing related to the ivory price. And this is seizures of ivory going out of Kenya. And what you see is it's pretty stable in that natality period. There's ivory flowing, but it's kind of a consistent amount. And the black line is the mass of ivory. In 2009 it surges and it's bouncing around up here in the tons category. This is seized ivory coming out of Kenya. So 4 tons of ivory kind of stuff, a lot of ivory. And the gray is the percent of the seized ivory that's destined for China. And so in the beginning, in the early part of the decade, we're seeing a very little ivory flow to China. And then we have sort of this phase shift in about 2007, where ivory predominantly is going to China. And so we're seeing these numbers. And this is I've been attacked for showing these numbers because they're very raw, and it really depends on effort. But there's been sort of some statistical approaches. I'm just going to throw in this is the 2009-8, that natality to mortality shift. And so when you do these modeling efforts, what you see is this is the number of ivory seizures happening, estimated, and the relative weight. And so what you see is this, because it's a model, it's smooth, but you just see at 2009, it really starts going up. 2011 is a disaster, and this is the weight of ivory. So we're seeing globally an escalation of the ivory flow, and it matches pretty well what we see in the Kenya records, which aren't modeled or aren't modified. And it matches pretty precisely in timing to what we saw in our system. And again, this is the China proportion going to China. 2011, seized ivory, 40% was headed to China, Hong Kong, Macau. China and Hong Kong being the same. So we figured that out. But for Samburu, we know what's going on in Samburu. It's kind of a nice story, and we really wanted to be able to adapt this. We're monitoring carcasses across Africa as part of a CITES mandated program. So CITES being the Convention on International Trade in Endangered Species. They instituted a program, the largest monitoring program they've done on an endangered species that's subject to trade, and it was called the Monitoring of Illegal Killing of Elephants, or MIKE program. And the idea was that we were going to do these carcass surveys across the systems, ours being one of them. We were one of the first ones they instituted. So we started, as researchers, we started doing this systematically, and I think we did a decent job of it. And it was instituted across the continent, and other places did variable levels of this. So some places did better, some places did worse. And the idea was that from that monitoring, we get an idea of changes. If we allowed one-off sales of ivory, we could see if there was changes on illegal killing. And so pro-trade people tend to say if you allow trade in ivory, you will flood the market with legal supply, and that will satisfy demand, and therefore illegal killing will decline. So if you trade, it will decrease illegal killing. And the anti-trade people say if we open up the market, it gives a signal that this is a natural resource, a commodity that can be sustainably used, and it will encourage consumption of this product, and therefore it will increase the demand, and also will act as a cover for illegal ivory. You have legal ivory being sold. How are you to separate if it's illegal or legal? So there's all these systems put in place to separate it, and it's this whole framework that people worked out is the idea. And so what we've seen is we've seen a couple one-off trades that were supposed to help suppress the illegal demand, and the last legal one-off trade to China happened, the first time to China happened in 2008. And so the timing is pretty nice in many respects. And so there's still a lot of debate about this. But the basic thing we wanted to do was try to get an idea of how many elephants are actually being killed across the continent, and what the status of the species is in these different areas, especially what a population status, and then what's going on with elephants in general. Are they declining, or what's happening? And we did this in 2 ways, and I'm not going to get too into it, but one, we just took the best sites. I'm a snob when it comes to data, so we took the best sites that have done the best monitoring and looked at what those are telling us and extrapolated on a regional basis. And the other one is we used a predictive model to try to predict the proportion of elephants illegally killed, so that proportion in the original analysis I showed you. And we based that on different covariates that we could get across the continent. So we would be able to estimate using the data collected in the MIKE sites, which there's 45 of them and about 20 were useful. We could predict illegal killing levels, the proportion of elephants, of carcasses being illegally killed at all sites where we know elephants are. And it turns out there's 306 populations that have been surveyed. And so we model it for all 306. So those are the 2 approaches we did. I'll show you later, but they're relatively the same result. Doesn't matter how you cut it. they show the same thing. And we do a basic demographic model where we basically assume exponential growth, sort of estimating population growth minus the poaching level minus the natural mortality level plus recruitment. And some of the recruitment stuff, I meant to mention this before, but the variability in the recruitment that I showed you in relation to ecological variation actually makes it kind of hard to do this. It's quite a stochastic process, the demographic processes. Anyway, so I won't get into the details, but we do our modeling exercise, and we can predict levels of illegal killing, and we can predict the subsequent population change across Africa. And so this is taking the best 19 populations actually that we had data, where we had matching census data and matching carcass survey data. And so when we lined them up, and basically what I'm showing here is the basic model assumes about 4 to 5% growth a year. And as you increase poaching, the median estimate of poaching eventually goes to a population collapse once you get to very high levels of the proportion of elephants illegally killed. So once you start getting every carcass you find in a system is illegally killed, you're starting to get a very strong signal that your population's collapsing. And if you have lower levels, then you can essentially what you get is you double the natural rate of mortality. That plus, so if you're doubling the natural rate of mortality, that exceeds recruitment and your population starts to decline. So if half the carcasses you find are illegally killed, you're going to be in danger that your population is starting to decline. And so we match this up. So this is the predictive is the error bars and the black line, and the red are my modeled results for these different populations, and the gray are census-based. And they matched up pretty well with our model, our simulation, and our empirical data matched up pretty well. And our model data and the census-based, so this is done by survey-based, aerial census, dung census, whatever, however they're doing it, those estimates of population change match quite well to our model-based estimates as well. So in terms of truthing, it did a decent job. And so what we did then is we threw this at all populations we could get data from, and this is sort of the estimates we pulled out. So this is starting at 2002. Central Africa actually basically had a year where it was probably not declining, and it's been declining pretty much consistently across the last decade. Eastern Africa really kicked in. That 2009, 2010 is the first year when it looks like it started declining. Southern Africa was 2011 was the first year by this approach, and basically the species level, these gray lines, I'm not sure if you can see them, represent populations, and the thickness tell you how big the population is in terms of numbers. So that's what all those gray lines are. And so Africa, the species, pretty consistent growth through most of the first decade of this century, and then we just started declining recently. So this is sort of our output. And to visualize this is 2002, 3, this is just going through time. And what we have here is basically, we're up to 2009. So green is growing. I'm not sure if those colors look okay or not. And red is really bad. But so it starts out pretty green across the scale, some really bad places. And 2009, what we're seeing is it looks like there's growth across. So Central Africa is a basket case. Western Africa is a basket case. We all knew that already. Geopolitically, they're unstable. There's all sort of extraction going on. They're removing coltan, they're removing diamonds, they're removing ivory, they're killing people. It's just par for the course. So that wasn't too exciting. And what we had is Eastern Africa and Southern Africa are looking pretty good around 2009. But then it kicks in and we see all of them start to reduce. There's a couple populations. So Namibia, northern Botswana, the Chobe system, that's Kafui in Zambia. Zimbabwe, we have very little information out of, but it's likely that it's not doing well. Mozambique's really bad. Tanzania is probably the biggest disaster. All of those are declining. Kenya's declining. Across the board, they all start to collapse, these populations. And then 2012 is still about the same as 2011. And then this throws you on I'm just throwing on the empirical result. I said I did 2 different approaches. I won't get too into it, but the empirical result and the model results match up pretty well. And the indication is things are, so DRC is going to extirpate their elephants, and the other areas are in serious trouble. And interestingly, so this is all model-based. We're starting to get some aerial census estimates out of Tanzania, and it looks like this model's underestimating the rate of decline, what's coming out, which was unfortunate for me. I hoped we were overestimating, but I think it depends on what's going on. So numbers, I just threw this on and it's really ugly. I'm sorry, but I'm just going to focus you on the top one. The big question we're always getting is what number are actually being killed? How many elephants are being killed? Actually, nobody cares about population rates. It's like, is it increased? That doesn't matter. No one asks that. They want to know numbers. And so this is based off an assumption that we know how many elephants are out there, which we don't. So I'm saying around here there's 500,000 elephants. And I'm doing this based only off the rates. So I'm just multiplying the poaching rate times this arbitrary number that we think's about right. So these numbers are meaningless. But that's what everybody wants to know. And so we're shooting out, right now, we're shooting out tens of thousands of elephants a year in Africa, which is astonishing when you think about how it's being done. Back in the previous periods, these were being done by militaries, and the governments were going in and they were removing a resource. It was a military operation, it was pretty clean. This is being done in a much less organized way now, but it's being done incredibly quickly and incredibly effectively across the continent. Another source, so this is Central Africa. I was working on another group with a lot of forest people doing surveys, and they were modeling population change. So this is sort of the distribution, or what we thought was the distribution in density in 2002, and this is based off dung surveys. We can't see them in the forest, so we do it all off spore surveys, trying to understand densities and how they're changing. And this is 2011. So they estimated a 62% decline in that 10-year period, and 30% reduction in range. And our model estimates 64% decline in that period for that same region. So it's pretty lucky. It might be random, that actually. But this reduction in range is a big deal. We're talking about reductions in range, and it's a criteria. It's something that I'm really interested in. The IUCN, ESA, all of these things, reduction of range is a big way we assess the state of endangerment of a species. And actually what you get in this kind of a system, especially with a species like the elephant, is you shoot them out and they're down to very low density and they're ecologically exterminated from that system. But by IUCN criteria and by ESA criteria, those are still inhabited range. And it's functionally it's not. And so that's a problem I think we need to address in the conservation community. Okay, so I got through what I wanted to show you. And so I guess for me, I'm really interested. I get asked this question a lot. But commercial trade, economic forces, using economic forces for ecological good is a huge movement. I'm sure some of you are involved in stuff like that or some of that type of work. And it's constantly asked of me with this particular instant is we're in an impoverished area. We need to have some valuation for national parks. In our system, our national park system is incredibly valued by our public. The government closes down. They leverage the national park to emphasize the cost of the government shutdown, right? Nobody cares the government shutdown. They care that they can't go see their national parks. And so that's what we saw the Obama administration do. They very highlighted fencing off the national monuments in all national parks. And it's in this time now that they're doing all these budget debates, the things that aren't touchable now as we just go forward are national park service and military. And so for us, it's like this public good, and we're willing to put money into it. But it's certainly not the case in developing nations. And so how do we raise revenue for these systems? Maybe in 40 years, they'll be at an economic level where they'll invest them, but now they don't. So we need to raise revenue somehow to protect these last vestiges of these biodiversity-rich areas and these iconic species. How do we do it? Economic models are simple. All we have to do this and it works, right? We sell a little bit of ivory and we're all good to go. Put it right back into conservation. So that's constantly brought up to me. And we have examples of success. Nile crocodile is getting exterminated across its range. It's a pest, and and they farmed them and it fed. I don't know if people wear crocodile skin boots anymore or not, but it was a big deal. You know more about probably this stuff.
Illegal in this country.
Yeah. Oh, it's illegal. Okay.
Yeah.
But so they did a lot of croc farming. Crocs are, it's fecundity, its reproductive capacity is quite different than some of these large mammals, but it's a solution that people say, oh, that's a successful solution for a conservation of Nile crocodile. Bear, the sun bear, the bear bile farming, which is, these guys are all hooked up to whatever, catheter, I don't know what you do, you milk their gallbladder, I'm not sure, I don't know anything about this. But this is them being this is bile farming. And so you can bile farm, and it's an economic solution. Does it reduce pressure? Without it, maybe we'd be having major poaching of black bears in the US and North America. We don't know. The sun bears might be exterminated without it. I don't know. But so people are tossing these out as examples of success. I think ethically is a different question. Is this acceptable? I'm not even going to that level. But farming is the solution, and it's big money. Our North American model is constantly portrayed as the solution to all conservation issues based on sportsman revenue licenses that funnels into conservation. It's a great success story. For the North American model to work, we had to have the Lacey Act, which made it illegal to trade wildlife across state boundaries. And without that, we were eradicating everything. We eliminated the passenger pigeon, we'd shot our elk and our deer down to incredibly low levels. They were going extinct. And it was, some people really got involved. So, that's an example of where, intercommerce, commercial trade, commercial utilization isn't going to work, or didn't work for a lot of our game species. Tigers are a disaster. There's more tigers in Texas than there are in the wild. Their densities are low. At the same time, there's tigers living in India the most densely populated subcontinent or area in the world. There's tigers living outside protected areas in India. So it's incredible what's going on in India in terms of conservation. But we're down to a few thousand tigers. Their range is completely gone. What's the solution for tigers? And tigers is a big one talked about farm. They do very well farming. The cats are also very fecund. So they're really a lot of success with tigers. And rhino is the big question. Rhino is going extinct. In our lifetime, the way things are going now, they're going to be exterminated. And I guess another nice thing with rhino, if you're into farming, is that they grow that horn annually. So you could harvest that horn annually, and you can farm them. And the question is that you guys know the value of rhino is worth more than, I think it's one of the most valuable commodities on the planet. It's worth more than heroin. And so rhinos are under enormous pressure. And what do we do with rhinos? People come to me and they're like, so we're losing species across the globe. In the last few years, we've lost species of rhino. So what do we do? Do we gamble with this? I mean, they're not doing well anyway. And so they bring up the elephant issue. And I'm just going to say, the hope, I don't want to be too negative on this story, but it's been a bad few years for us. And the real exciting thing for me is that we've had highest level recognition of this issue. Hillary Clinton and Kerry both are really strong proponents of conservation. On the Hill, the U.S. Congress allocates $2 million or $2.5 million to an elephant fund, and same for rhino and same for tiger. And that money they've kept through all this sequestration. I don't know how. And Obama put in an executive order about combating wildlife trafficking. They're leveraging this based on terrorism, saying that this ivory is being used by Al-Shabaab to fund terrorism. It's very tenuous, the links between it. But Lord's Resistance Army, Joseph Kony, you guys all know, Kony 2000 or whatever that was, those guys are definitely dealing in ivory. They're very desperate. They're dealing with whatever they can. So they're playing ivory for sure. And so using wildlife trafficking, it turns out it's one of the dominant illicit goods being traded globally, with weapons, with drugs, with illegal money, illegal oil. And so it is a security concern as well. And so just a few days ago, February 11th, we got ban on all commercial trade in ivory in the US. And this was a signal. I think this is more a signal globally. We crushed. So in 25 years, we collected 6 tons of ivory illegally in the U.S. U.S. Fish and Wildlife Service confiscated. They crushed it a few months ago, and this was really, so everybody's like, oh, what's the point of crushing it? Why don't we use that, flood the market, cover the demand, and it'll then drop, and illegal poaching will then drop because we have demand being satiated by 6 tons of ivory. It turns out if you look at our numbers, 6 tons of ivory is a couple weeks of ivory being consumed today.
Couple weeks.
3 weeks. several tons a year being confiscated. That's what's confiscated. So the question is, we don't know with confiscation how that relates to numbers of actual being traded. So the drug trade, I think they confiscate 10%. So who knows with this? We don't know. But it's hard to actually. I could make up numbers too and tell you what those numbers, the made up numbers I showed you before, how that extrapolates to made up numbers of tons of ivory. But I'll spare you guys that. But this was really interesting. So we crushed ivory. A lot of people, I got interviews, people asking me about this. I think this was just a diplomatic communication of the U.S. Instead of classically, the U.S. is always pointing fingers and saying, oh, you have a problem. China, you're the problem with this environmental disaster. Meanwhile, the U.S. is a major consumer of exotic species. It's supposed to be one of the primary consumers of ivory, substantially below that of China, but we're still supposed to be the number 2 consumer of ivory. And so we were sending a signal that we're going to deal with our house. We're going to clean up our house and deal with our domestic problem. And we encourage you, everybody in the world as well, to clean up your house. And China subsequently also crushed 6 tons. Hong Kong is now talking about crushing 30 tons. Philippines crushed. So it actually has been interesting for me to watch the diplomatic process. And this communication is happening. And now this domestic ban, again, is communication saying we're domestically banning. All of our great hope is that China will domestically ban ivory, and that we think would change. But the other tricky part of this is once you whet the appetite for a product, sometimes it's hard for even the governments to control, even a government like China, which is pretty effective. Anyway, I'm out of time. I just want to thank you guys. It's a question I'm very interested in, is how do we play with these economic drivers to solve conservation problems? Is economic the bane of, is it going to destroy everything we want, or is it a solution, or how can we leverage it? And I don't know the answer. And I'm very interested in the nuance of those types of solutions. But I do know we need to figure out solutions quickly, somehow, and I'm not sure what they are. So I'm welcome questions and comments on that. But I just wanted to say there's a lot of people that have contributed to this. These are my co-authors on that work, and I haven't published it yet, but I'm hoping to do that sometime. And yeah, so it's been a very collaborative, a continentally collaborative project together. It's one of the largest monitoring projects, I think, globally, and I hope the way we're able to leverage that data is giving us some inference on the processes going on. With all that effort, we hope it's useful. I've also had the wonderful job of going into long-term monitoring projects and said, oh, you've collected nothing of use. And that's a fun job to have. People, it's like your hatchet man. Like, I'll give you a free ticket and put you up in a hotel, but you got to go do that. And they don't tell you until day 3 of the conference. You're like, wait, what are we, this stuff's not, you can't use that. Yeah, you need to tell them that. So anyway.
Okay, on an optimistic note. Thank you.
Yeah. Thank you. Yeah.
One thing that you touched on, but I think is a really important component that's lost, is that what we're seeing here is really the tip of the ecological iceberg.
Right.
That the seed dispersal, for
right.
example, in forest elephants,
yeah.
in Central Africa,
that service is gone.
disperse over 100 species of trees,
right.
more than any other species, and I would say 50% of those trees are only dispersed by elephant.
Right.
And so,
including some economically valuable ones that are being harvested.
Malawi, which
right.
is, for example, one of the most one of the most valuable.
Which, interesting enough, so we've been talking to Chinese timber companies, and they are interested in that. They're interested in that information. So I don't know how interested, but that to me is something I think you can work. There's a lot of people we can work with.
But I think it seems to me that it's something that needs to be brought into the debate.
Yeah. The ecological function's critical. I mean, we've extirpated the ecological role of most species across 90% of the continent, African continent already. It's going to be, more land is going to be impacted in the future. But the Central African forest, number 2 sequestrating forest on the planet, it's being selectively logged. It's not clear cut. It's not cut and burn the way the Amazon is. So actually, when you do the prognosis of the state of the Central African forest based on remote sensing, has been quite positive relative to other tropical forests. And that it's not being degraded at the same rate as these other places. And it's because they're selectively logging it. But as you selectively log it, you put the road networks in, and all of its vertebrates are being harvested.
One sidebar too, with respect to China, they're building a deep water port right now in southern Cameroon.
Yeah.
That is going to have rail lines extending into DRC, and they're doing the same on the East Coast now. So
Yeah.
this port, which is almost half the size of the port of LA, will be done next year.
Yeah.
And so,
Yeah.
critical.
It's going to change Africa is going to change rapidly. And so that's the future we want to deal with. Bob?
You talked about some global action, but I just wondered what sort of local response, local action you might envision, like in Samburu, for instance.
Yeah.
Could they increase surveillance, use
Right.
drones or whatever?
Right.
That
Yep.
could be done elsewhere,
Right.
or perhaps reimburse the pastoralists for saving elk.
Right.
If they decrease
Yeah.
the number that are poached.
So I could do another talk on that. So the Samburu region it's an incredibly dynamic place, what's going on there in terms of conservation. And it's one of these places I'm quite certain will do okay through this. I think we're going to hold the line there. And there's a lot of effort going on through community conservation. And actually, interestingly, I mentioned how politically volatile that area is. The number one the benefit you get through community conservation there, the first benefit, the reason why you get the communities to buy in and protect their land and start protecting animals, is security against tribal warfare. And we're leveraging that. Security for tribal warfare is security for wildlife, it's security for people, it's security for kids, and it allows all sorts of other things. It's going to allow new types of development to happen, be that good or bad, but it's going to change the dynamic out there. And so community conservation in that area has been incredibly successful. But it's not your typical economically modeled base. There is economic benefits. There's jobs coming in that are floated primarily through USAID at the moment. And there are tourism coming in, and so there are economic benefits as well, but those will develop over time. For me, the immediate benefit, the reason why you get buy-in in our system is purely security. And so my work actually, I can give you my grant list. My grants have been towards anti-poaching work in the last few years. And our research project has switched from really a behavioral research project to a much more integrative, interactive project facilitating data analysis across the continent from a lot of people and data collection to get at trying to answer this question. So I did not see myself this wasn't my life that I thought I'd be doing. And it's totally switched. That's what I think about all the time, because he responds to it. Yeah.
So I'd like to talk a little bit about the issue of commercialization and whether that's good, in other words, whether you can flood the market, whether you can
Right.
create a healthy, positive market or not. And in the experiences that I have, as you know, with reptiles, and there, I'm sort of trying to go through my laundry list of examples, and I think the example that's most relevant is marine turtles. So
Yeah.
there are, you might know, in like the Grand Caymans, there are several green sea turtle farms
Right.
that have been going since the 60s.
Right.
And the idea was to flood the green sea turtle market.
Right.
Green turtles, they're like elephants. They take 30, 40, 50 years sometimes to reach sexual maturity.
Right.
They take forever. It's
Right.
horrible that way.
Right.
But at least they lay a lot of eggs.
Yeah.
Right. And
Right.
so that's a good thing. And that I think the entire community has felt was just unsuccessful.
Right.
It was such a drop in the bucket, and
Right.
what it did was it sort of promoted an illegal market
Right.
in
Hmm.
sea turtle
Right.
products, and
Yep.
just
Yeah.
all of that stuff.
Right.
There are other ones that have been successful. The U.S. turtle diamondback terrapin was one that was almost extinct.
Yeah.
They were selling for $150 a dozen.
Right.
In the 1800s, and that's
Yeah.
a lot of money back then.
Right. Yep.
Almost went extinct. They were farmed and flooded the
Yeah.
market and
Right.
pulled out.
Faster age of maturity, probably, or no?
Yeah, it's 6-8 years to sexual
Yeah.
maturity, and government-sponsored breeding programs.
Right.
And plus, it was only the elite cared about them.
Right.
As soon as they became cheap, people lost interest
Yeah.
You know, 'cause they
Yeah.
just-
Well, that's so. The other thing I didn't get into is what ivory is being consumed for.
Yeah.
And there's a lot of debate about that.
And
But
so-
it's an investment. It's an investment.
So, I mean, are there any models that you know of for elephants, you know, that can suggest any way that the commercial side of it could benefit them? I see them as
Yeah.
just being like ring turtles, where
Right.
it's just a no-win, and the only way
Yeah.
to do it is just.
Yeah. Well, you know, in southern Africa, they can do it where they have highly militarized. Well, this is their claim with rhino, and it turns out that they've been losing rhino. Now that the price is at a level, they can't deal with it either. But they're much more militarized, much more. Everything's been denuded in the landscape, and now they have fenced parks. Is all they have left.
Yeah.
And so much more controlled setting. And so they've always been proponents that they can do this properly, and I think they can for their population. But the repercussions,
raise them, or
they can harvest ivory sustainably from their populations, and it won't affect elephant population levels in South Africa. It's very different when you talk about the species and the whole of Africa, and how does that trade relate to the species? And there is not capacity in Central Africa to do that. In East Africa, there is not the capacity to do that sustainably. And we see possibly we have high-level corroboration of governments across different places in the continent where you might have very high-level people involved in this harvesting, and right now in the illegal trade, and that's the threat for trying to implement that in these other places. And so it's another tricky thing is spatially it might be successful in some areas and it won't in other areas. How do we deal with this in the conservation context? I'm not sure. So it's not simple, but if you look at it as a species issue, I would say right now we have no evidence that we can do it. We know that the legal trade is highly regulated, it's permitted in China, it's totally flaunted. There's illegal ivory flowing all over the place. And Chinese government's involved in maintaining that legal trade, and it's not working. So, sorry.
So this is going to be a completely crazy idea, but it's like the reason people buy ivory or rhino is that they know that what they're getting is ivory or rhino.
Right.
So I'm wondering, has anybody thought of A, making really good cakes and getting around it, and B, on the side, letting people know, hey, there's all this fake stuff out there, you don't know much about it.
Yeah. Right.
Make the value go down by,
Right.
by concept.
Right. Well, interesting. So China is the great land of fakes, and it's full of fake rhino horn, actually, and it's made real rhino horn. So now, if you're really high end, you get the rhino horn scraped in front of you, and it's very valuable, that rhino horn. And so, yeah, I think again, I think theoretically you come in with these ideas, and in practice it might go the other way. It might even be making it more valuable, and because there's so much fake rhino horn around, I'm not sure. So, and people have come to me, they're talking about the 3D printing ivory. It turns out ivory has it's really complex. It's a wonderful carving material. It's absolutely fabulous, and it's beautiful. And so, can we synthesize it? Well, the way it grows, it has these integrated growth rings that make it so that it's carvable in any direction, any angle. And I don't know if you can synthesize that or not, but that'd be great if we could 3D print it. And so people have asked me, people played with that. I don't know that's going to happen. It's valuable enough that it seems economically if you can do it. But mammoth, the other thing is mammoth ivory's been played a lot. Massive volumes.
Maybe from Malcolm?
Yeah, to what extent is there an organized crime component to all of this?
Massive.
It sounds, because this sounds like the war on drugs.
Yeah.
This is not just happening spontaneously. There's a lot of logistics involved. There's huge money flows involved, as well as the commodity itself.
Right.
So is there an international mafia that's behind this?
I don't know. I'd like to know. We're trying to figure out. That's a big part of the executive order by the Obama administration. It's a big part of our interest is these guys are trading. Wildlife has become a highly lucrative, unregulated economic good. They can trade. They're trafficking people. they're trafficking weapons, they're trafficking drugs, and it looks like there's probably a lot of things are related. It's hard to know, and it's interesting, like we're having a lot of effort to arrest people, and you're arresting the guy in Samburu that went and shot an elephant, and it's like, why are we never arresting the port authority where literally 100 tons of ivory has flown through last year? You know, why has no one ever been arrested on that? And the reason is because they're incredibly powerful people, is the only logical thing I would say we can conclude. But yeah, I don't know. With the sting operations, the stuff going on, Kenya is really neat, the stuff that's going on there. And they have totally drastically revised their penal code in relation to wildlife crime, and there's legislative, grassroots legislative observers that report online what they're seeing, what judge is making what decision about what case. And it's really neat, the groundswell of transparency going on in Kenya. And it gives me, like, the Kenya government is clearly not, they're allowing this to go through, they're clearly not driving this trade. But there's obviously very powerful people in the country that are. And so there's dynamics going on. I'm not privy to them, I don't know how it's working, but there are some major things going on within these countries right now about this issue. And so I'm hopeful, I'm definitely hopeful.
Let's grab it on that note.